morning, students. Welcome to the fourth session of Sequences and Series. In the last class, we started off with problems based on AP. In today's class, we shall continue with some more problems on AP. Write down question number 4. How many terms of the AP? How many terms of the AP? Minus 6, comma, minus 11 by 2, comma, minus 5, comma, so on. How many terms of the AP? Minus 6, comma, minus 11 by 2, comma, minus 5, comma, so on are needed to give the sum minus 25 are needed to give the sum minus 25. I repeat the question one more time. How many terms of the AP? Minus 6, comma, minus 11 by 2, comma, minus 5, comma, so on are needed to give the sum minus 25. Okay, look here. What is the question? What is the given AP here? The given AP is minus 6, comma, minus 11 by 2, comma, minus 5, comma, so on. So what is the first term of this AP? Okay, we'll start with the solution. The given AP is, what is the given AP? Minus 6, comma, minus 11 by 2, comma, minus 5, comma, so on. So what is the first term of this AP? First term is minus 6. So we can write small a equals minus 6. Then what is the common difference of this AP? Small d, common difference is second term minus first term. That is minus 11 by 2 minus of minus 6. You might also do third term minus second term also. Okay. Now on further simplifying this, we get what? Minus 11 by 2 plus 6. Taking LCM as 2, we get minus 11 plus 12. 12 minus 11 is 1 by 2. So we got common difference as 1 by 2. Now what is the question asking us to do? How many terms of this AP is required to give the sum minus 25? So what is minus 25? Minus 25 is nothing but Sn, right? Minus 25 is nothing but sum of some terms of this AP. Now we have to find out how many terms. The sum of how many terms is needed to give the sum minus 25. So in other words, what is the question asking us to do? It is asking us to find out the value of n. So we'll use the formula of Sn for an AP. Sn formula is what? N by 2 into 2a plus n minus 1 into d. So from that formula, we are going to try to find out the value of n. Okay, now look here. Sn, we know it to be n by 2 into 2a plus n minus 1 into d. So we substitute the values of Sn, a and d and try to find out value of n. So what is Sn? Sn is given to be minus 25 equals n by 2. N value we do not know, so write it as n by 2 into 2 into a. A value is minus 6 plus n minus 1. What is d value? It is 1 by 2. Okay, we will simplify this equation and find out n. I will take 2 on the LHS, multiplying 2 with minus 25. We get minus 50 equals n into 2 into minus 6 is minus 12 plus, I can write this as n minus 1 by 2. N minus 1 whole divided by 2. Okay. LHS remains as it is, minus 50 equals n into. I will just take the LCM as 2 inside the brackets. Okay. Taking LCM, what do you get? Minus 24 plus n minus 1. Minus 24 plus n minus 1. Okay. Taking this 2 to the LHS, what happens? Minus 15 into 2 is minus 100 equals n into. Minus 24 minus 1 is minus 25. So this becomes n minus 25. Okay. LHS remains as it is, minus 100 equals, I multiply n here, what do we get? N square minus 25n. Taking minus 100 to the RHS, what happens to this equation? N square minus 25n plus 100 equals 0. Okay, so we have got a quadratic equation in n. We need to solve this quadratic equation. We might get two values for n, and we are going to see which value satisfies. Okay, you might pause the video, work it out, and then play it again, see whether you have got the same answer. Now, thinking about the factors for this quadratic equation, we might take the factors as 20n, minus 20n, comma, minus 5n. Okay, so the factors, we have 100n square. I can take the factor as minus 20n and minus 5n. Product of minus 20n and minus 5n gives us plus 100n square, and sum of these two factors, minus 20n plus minus 5n, gives us minus 25n. Okay, so I can write this as n square minus 20n minus 5n plus 100 equals 0. I can take common as n here from the first two terms. I have n minus 20 minus, I can take minus 5 common here. So I am left with n minus 20 equals 0. Further simplifying this, okay, so we have n into n minus 20 minus 5 into n minus 20 equals 0. So I can write this as what? N minus 5 into n minus 20 equals 0. N minus 5 into n minus 20 equals 0. So what are the values of n? N can take the value 5 or n can take the value 20. So we have found out the values of n. So we can have the sum of the first 5 terms of this AP, then also we get the sum minus 25. Adding the first 20 terms of this AP also gives the sum minus 25. Okay, moving on. Next problem, write down this problem. In an AP, if P term, in an AP, if P term is 1 by Q, in an AP, if P term is 1 by Q and Q term is 1 by P and Q term is 1 by P, prove that the sum of first PQ terms, prove that the sum of first PQ terms is 1 by 2 into PQ plus 1. Prove that the sum of first PQ terms is 1 by 2 into PQ plus 1, where P not equal to Q, where P not equal to Q. I repeat the question once again. In an AP, if P term is 1 by Q and Q term is 1 by P, prove that sum of first PQ terms is 1 by 2 into PQ plus 1, where P not equal to Q, where P not equal to Q. Okay, look at the question here. What is given in the question? It is given that the P term is 1 by Q. So in other words, I can denote P term by AP equals 1 by Q, and Q term I can denote it as AQ. It is nothing but equal to 1 by P. We have to prove what? The sum of first PQ terms. So the sum of first n terms of an AP is denoted by the symbol Sn. Similarly, the sum of first PQ terms of an AP is denoted by the symbol SPQ. So we have to show that SPQ is equal to 1 by 2 into PQ plus 1. It is also given that P is not equal to Q. Okay. We will use what is given in the problem. Okay. We start the solution like this, or we can start it here itself. Let AP, we will write what is given. Let AP is 1 by Q and AQ is 1 by P. We have to prove that. We have to prove that what? SPQ equals 1 by 2 into PQ plus 1. Okay, now if A is the first term and D is the common difference of AP, how can I write the P term of the AP? Okay, A suffix P. If A, small a is first term, small d is common difference, I can write the P term AP as A plus P minus 1 into D, right? But what is AP? It is nothing but equal to 1 by Q. We will take this as equation number 1. Then how can we write AQ as A plus Q minus 1 into D? But what is AQ equal to? It is nothing but 1 by P. We will take this as equation number 2. We will try to solve equations 1 and 2 simultaneously and see if we can find out values of A and D. Okay, we have got two equations, equation 1, equation 2. We are going to simultaneously solve these two equations and try to find out values of A and D. You can see that you have A here, I have another A here. So if I perform the difference between the first and the second equations, A gets cancelled, right? So I am left with only D. I can find out value of D. So I will perform this operation. Equation 1 minus equation 2 gives. So what does equation 1 minus equation 2 give us? I am subtracting this minus this. This I am subtracting from this, or I am performing 1 minus 2. So A and minus A get cancelled. All these signs changes to minus, minus and minus. So I'll write it here. So minus plus A becomes minus A, plus becomes minus here, plus 1 by P becomes minus 1 by P. A minus A and A get cancelled. Then P minus 1 into D minus q minus 1 into d. So I get p minus 1 into d minus of q minus 1 into d equals, what is left on the RHS? 1 by q minus 1 by p. 1 by q minus 1 by p. Okay, so now we have p minus 1 into d minus q minus 1 into d equals 1 by q minus 1 by p. I will take d common on the LHS. So when I take d common on the LHS, what do I get? P minus 1 minus of q minus 1 equals 1 by q minus 1 by p. Okay, now look here, inside the brackets we have a minus 1. Minus into minus 1 becomes plus 1. So these two cancels out each other. What is left on the LHS? We are left with d into p minus q. Okay, so all that is left on the LHS is d into p minus q equals, I can take the LCM as pq on the RHS. When I take LCM as pq, what do I get? I get p minus q in the numerator. So I get p minus q by pq on the RHS. On further simplification, I can cancel out p minus q and p minus q. So what am I left with? So what is value of d? D equals 1 by pq. So we have found out value of d to be 1 by pq. Now that we have found out value of d, we shall substitute value of d in one of these two equations, find out the value of a. So we'll put d equals 1 by pq in equation 1. Okay, d equals 1 by pq in equation number 1. So what happens to equation 1? We get a plus p minus 1, value of d is 1 by pq equals 1 by q. All I have done is I have put the value of d as 1 by pq in equation number 1. So equation number 1 becomes a plus p minus 1, d value is 1 by pq equals 1 by q as it is on the RHS. Okay, on simplifying this, a plus, I will just take this whole term on the RHS. Okay, I will take p minus 1 into 1 by pq on the RHS. What happens? I get 1 by q minus, plus becomes minus p minus 1 by pq. So I get a equals 1 by q minus p minus 1 by pq. On further simplifying this, okay, so what is the LCM here? I can take the LCM as p into q. So what remains in the numerator? I have p minus of p minus 1. So when we take the LCM as pq on the RHS, we get p minus of p minus 1 by pq, plus p minus p cancels, minus into minus 1 is plus 1. So what is a equal to? A, we are getting it as 1 by pq. So value of d is also 1 by pq, value of a is also 1 by pq. But coming back to the question, what should we prove? We have to prove that SPQ equals 1 by 2 into PQ plus 1. So to do that, we will use the formula of Sn. What is Sn? N by 2 into 2a plus n minus 1 into d. So if Sn value is n by 2 into 2a plus n minus 1 into d, what is SPQ? So what is SPQ? In the place of n, I have to put PQ. So we get PQ by 2 into a. What is value of a? Just now we found out value of a to be 1 by PQ. I substitute here 1 by PQ plus n. N is again PQ. PQ minus 1 into d. D value is again 1 by PQ. So we have used the formula of Sn and we have substituted. In the place of n, we have substituted PQ. In the place of a and d, we have substituted 1 by PQ. Okay. We will simplify the RHS and try to get 1 by 2 into PQ plus 1. So that is what we are trying to prove. SPQ equals 1 by 2 into PQ plus 1. Okay. So PQ by 2 as it is outside, 2 into 1 by PQ is 2 by PQ plus PQ minus 1 by PQ we have. Okay. We'll take the LCM here. Taking the LCM as PQ, I can write this as 2 plus PQ minus 1 whole divided by P into Q. What cancels here? PQ cancels with PQ. What happens to this? 1 by 2 into, look at the terms inside the brackets, PQ as it is, 2 minus 1 gives us what? Plus 1. What is the LHS? LHS is nothing but SPQ. So what have we done? SPQ equals 1 by 2 into PQ plus 1. We found out values of D and A using the information given in the problem. Then we substituted. We have proved that SPQ using the formula of Sn, right? We found it out to be 1 by 2 into PQ plus 1. Moving on, write down the next problem. If the sum of certain number of terms, if the sum of certain number of terms of the AP 25, 22, 19, so on, 25, 22, 19, so on, is 116, full stop. Find the last term. Find the last term. I repeat the question once again. If the sum of a certain number of terms of the AP 25, 22, 19, so on is 116, full stop. Next sentence, find the last term. Find the last term. Okay. Look at the question. What is the question telling us? The sum of certain number of terms of the AP. Which AP? This AP. 25, 22, 19, so on is 116. So we'll start the solution like this. Okay. So this is the solution. The given AP is 25, 22, 19, so on. So if this is the given AP, what is the first term of this AP? First term of this AP is 25. So I will write A equals 25. What is common difference? D. How do you find out common difference? Second term minus first term, or third term minus second term. So second term is 22 minus first term is 25. We get it as minus 3. So we have used the given AP, found out A and D. A is 25, D is minus 3. So look at the question again. What is given there? Sum of certain number of terms of AP is 116. So what is 116? 116 is nothing but Sn. So the sum of certain number of terms of the AP is Sn. Sn equals 116. What is the question asking us to do? It is asking us to find the last term. So to find the last term of this AP such that the sum is 116, we first of all need to find out value of n, right? First we need to find out value of n. Once we find out value of n, we can find out the last term by using the general formula, the general term of an AP. Okay. For now, to find out n, we have got Sn equals 116. We have got value of A to be 25, value of D to be minus 3. We have to find out value of n. So we'll use the formula of Sn again. So what is Sn? Sn is nothing but n by 2 into 2a plus n minus 1 into d. The same formula we are going to use here. So what is Sn? Sn is nothing but n by 2 into 2a. 2 into a. Value of a is 25 plus n minus 1. n minus 1 into d. What is d? D is minus 3 equals, what is the RHS? RHS is nothing but 116. So what have we done? We have just used the formula of Sn and we have written here. We have substituted the values of A as well as D. Okay, we'll simplify this equation to find out value of n. N by 2 into 2 into 25 gives us 50 minus 3. I multiply with this binomial. So what happens? Minus 3 into n is minus 3n. Minus 3 into minus 1. It's plus 3 equals 116. Okay. On further simplifying this, what do we get? On simplifying this further, we get n by 2 into 50 plus 3 gives us what? 53 minus 3n equals 116. So we've got n by 2 into 53 minus 3n equals 116. I multiply 2 on the RHS. What happens? We have n into 53 minus 3n equals 2 into 116. What do we get? 2 into 6, 12. 2 ones are 2 plus 1, 3. 2 into 1 is 2. So we get 232. Multiplying n with this binomial, what happens? We get 53n minus 3n square equals 232. We will take these two terms on the RHS. What happens to the equation? We get 3n square minus 53n plus 232 equals 0. So again, for this problem also, we have got a quadratic equation in n. We will solve this quadratic equation, find out the values of n. Okay. The factors for this quadratic equation are minus 24n and minus 29n. Okay, so I'll write this like this: 3n square minus 24n minus 29n plus 232 equals 0. You can work this out. If you are not able to find out the factors directly, use the formula method. Okay, so we've got 3n square minus 24n minus 29n plus 232 equals 0. Okay, we'll simplify this. I take 3n common. So what do we get? n minus 8 is left out. I take 29 minus 29 common. If I take minus 29 common, I am left with n minus 8 equals 0. So the factors are minus 24n, minus 29n. When we took out common factors, I took out 3n common from the first two terms. I got n minus 8. I took out minus 29 common from the next two terms. I got n minus 8. So what are the factors here? I can write this as n minus 8 into 3n minus 29 equals 0. So what are the values of n here? Values of n can take the value 8 or n can take the value 29 by 3. But what is n? N is nothing but the number of terms, right, or the position of the term. N denotes number of terms or position of the terms. Can n be a fraction? No, it must be a natural number. N denoting the position can be either 1, 2, 3, 4, 5, 6, so on. It cannot be 2 and 3, in between 2 and 3. So this is a fraction, 29 by 3. N cannot be a fraction. So that is why we have to consider the value of n to be 8. So n we found out to be 8. What is the question asking us to do? We have to find the last term. So how can we find the last term? We will equate, okay, we will take the general term of an AP. What is the general term of an AP? an equals a plus n minus 1 into d. So using this general term of an AP, we are going to substitute for values of a, d as well as n, and then find out an. That will be the last term of this AP. Okay. So what is value of a? Value of a is 25 plus value of n is 8. 8 minus 1 into d. Value of d is minus 3. Okay. So what do we get? We get 25. 8 minus 1 is 7 into minus 3. 7 into minus 3 is minus 25. So 25 plus of minus 21. 25 minus 21 is nothing but 4. So 4 is the last term of this AP, such that you have to get the sum of terms as 116. Moving forward, write down the next question. Find the sum to n terms of the AP. Find the sum to n terms of the AP whose k term is 5k plus 1, whose k term is 5k plus 1. I repeat the question once again. Find the sum to n terms of the AP whose k term is 5k plus 1. So we have to find sum to n terms. Sum to n terms is Sn. We have to find Sn if k term is nothing but ak is 5k plus 1. Okay. Look here, to find out sum to n terms of AP, right, we have to first find out what A is and what D is. We have to find out the first term A as well as the common difference. The only information given here is the k term is 5k plus 1. So we'll use that information. Solution given, what is given? AK, that is the k term is 5k plus 1. If small a is first term, small d is common difference, what is AK? AK will be nothing but a plus k minus 1 into d equals 5k plus 1, right? So if a is first term, d is common difference, ak will be nothing but a plus k minus 1 into d. Now I can write this as a minus d, okay? We are multiplying d to this binomial, d into k minus d. Right? So a minus d, I can write it together plus, which is the other term, k into d. So the LHS, I can write it as a minus d plus d into k or k into d. What is on the RHS? We have 5k plus 1. Now look here. We have a constant term and a term with k. A k term we have, a constant term we have. Again on the RHS, we have a k term and a constant term. We can equate the coefficient of k on both sides and the constant terms. So equating coefficient of k on both sides, equating coefficient of k on both sides, what do we get? We get value of d to be 5, right? All I have done is I have equated coefficient of k on both sides. I have d with k here on the LHS. On the RHS I have a 5 with k. So equating coefficient of k on both sides, I get d equals 5. So now that I have got d equals 5, I have to find out value of a. Similarly, following the same idea, equating the constant terms on both sides, okay? Equating constant terms, equating constants on both sides. What do we get? We get what? A minus d equals 1. We get a minus d equals 1. Now, what is value of d? Value of d is 5. I substitute for value of d here, find out value of a. I substitute value of d to be 5. So this becomes a minus 5 equals 1, on further simplifying this, taking minus 5 on the RHS, we get what? A value to be 6. So we have found out value of A to be 6, value of D to be 5. What must we find out? We have to find out the sum to first n terms of this AP. We have got the value of A to be 6, value of D to be 5. We'll use the formula of Sn. What is formula of Sn for an AP? It is n by 2 into 2A plus n minus 1 into D. So we'll use that formula. What is Sn equal to? Sn is n by 2 into 2A plus n minus 1 into D. We have got the value of A to be 6, value of D as 5. We substitute here. So what happens to this? N by 2 into 2 into A value is 6 plus n minus 1 into D. What is value of D? Value of D is 5. Further simplifying this, what do we get? N by 2 into 6 is 12 plus, I can write this as multiplying 5 with this binomial. I get 5n minus 5. Okay, n by 2 as it is, we'll simplify inside the brackets. 12 minus 5 gives us plus 7. So I can write this as 5n plus 7. So what is sum of n terms of this AP? It is n by 2 into 5n plus 7. Moving on, write down the next problem. If the sum of n terms of an AP, if the sum of n terms of an AP is Pn plus Qn square, is Pn plus Qn square, where P and Q are constants, where P and Q are constants, find the common difference. Find the common difference. Okay, I repeat the question once again. If sum of n terms of an AP is Pn plus Qn square, where P and Q are constants, find common difference. Look here. What is given in the question? It is given that sum of n terms of an AP is Pn plus Qn square. So in other words, what can I write? We start the solution like this. Given, it is given that sum of n terms. What is notation for sum of n terms? It is Sn. Sn is equal to Pn plus Qn square. What is the question asking us to do? The question is asking us to find out the common difference D. So we'll use the formula of Sn for an AP. What is formula for Sn? N by 2 into 2A plus n minus 1 into D. So we'll use that here. Sn is n by 2 into 2A plus n minus 1 into D equals Pn plus Qn square. Okay, so this equation becomes n by 2 into 2A plus n minus 1 into D on the LHS. RHS is Pn plus Qn square. Okay, we'll simplify the LHS. On simplifying the LHS, I can write n by 2 as it is. Okay, we'll write 2A. I'll multiply D with this binomial. So what do I get? N into D is ND. Minus 1 into D gives us minus D equals, what do we have? Pn plus Qn square on the RHS. Okay, now on the LHS, I will multiply this n by 2 inside the brackets. Okay, what happens? I have n by 2 into 2a. N by 2 into 2a gives me what? N into a. N by 2 into 2a, 2 and 2 get cancelled, I get n into a. Then n by 2 into nd, what do I get? Plus n square into d by 2. Okay, n by 2 into nd, I get what? N square into d by 2. Then n by 2 into minus d, what happens there? Minus n into d by 2. So n by 2 into minus d is minus n into d by 2. The RHS remains as it is, Pn plus Qn square. Now look at the LHS further. Okay, I will write the n square term first. Okay, n square into d by 2. Okay, then I will write the n terms next. These two are the n terms. I will take n common from these two terms. So plus n, what happens? A minus d by 2. Similarly on the RHS, I will write the n square term first, then the n term. Okay, so this is Qn square plus p into n. So we have an n square term and an n term on the LHS, an n square term and an n term on the RHS. So just like the previous problem, what can we do? We can equate the coefficient of n square. Okay, you can see that if I equate coefficient of n square, I get d by 2 equals q. But if I equate the coefficient of n, I have the a term with the d. So that won't give me the common difference. So it is wise to equate coefficient of n square on both sides. So equating, last step is equating coefficient of n square on both sides. Equating coefficient of n square on both sides, we get what? D by 2 equals q. Okay, on further simplification, I can write this as d equals 2 into q. So what is the common difference of this AP? It is 2 into q. Write down the next problem, students. This is the last problem under AP. Insert 5 numbers between 8 and 26. Insert 5 numbers between 8 and 26 such that the resulting sequence is an AP. Insert 5 numbers between 8 and 26 such that the resulting sequence is an AP. Okay. In the last class, we discussed how to insert certain n number of finite terms between any two numbers such that the resulting sequence will be an AP. So we'll do that now. What is the first step? We always find out the common difference d. What is the formula for common difference d? D is nothing but equal to b minus a whole divided by n plus 1. So what are a and b? A and b are the two given numbers. Here, what is a equal to? Here I can take a as 8 and b as 26. So a is 8, b is 26. What is n? N is the number of terms to be inserted in between the given two numbers. So what is n here? We have to insert 5 numbers, hence n will be equal to 5. So first we will find out the common difference D using this formula, then we are going to find out the corresponding terms. Also, let the 5 required numbers be A1, comma A2, comma A3, comma A4 and A5. Okay, we'll first find out the common difference D. D will become what? B minus A. B is 26, A is 8, whole divided by n plus 1. N is 5, 5 plus 1. So what is 26 minus 8? We get 18 divided by 5 plus 1 is 6. So this is 6 3s are 18. So the value of D is 3. Now, how do we find out A1, A2, A3, A4, A5? So what is A1? A1 is nothing but A plus D. What is A? A is 8. What is D? D is 3. So what do we get? 8 plus 3, which is equal to 11. So A1 is 11. What is A2? A2 is A plus 2D, right? A2 is A plus 2D. A value is 8 plus 2 into D value is 3. So what do we get? 8 plus 6, it is 14. Then what is A3? A3 I can write it as A plus 3D. A value is 8. 8 plus 3 into D value is 3. 3 3s are 9. 9 plus 8, we get it as 17. Okay. A4, fourth number is A plus 4D. A value is 8 plus 4 into 3. 4 3s are 12. 12 plus 8, we get it as 20. And the last number, A5, is A plus 5D. A is 8. 8 plus 5 into 3. 5 3s are 15. 15 plus 8, we get 23. So these are the 5 numbers to be inserted in between 8 and 26, such that the resulting sequence. So what will be the resulting sequence? 8, 11, 14, 17, 20, 23, 26. Okay, so you can see that this sequence is an AP. Okay, so we have inserted 5 numbers 11, 14, 17, 20 and 23 in between 8 and 26. So you can see that the resulting this sequence is an AP. So that is about AP. In the next class we will continue with GP. Thank you.